recap whatever we studied in last class. Last class we studied, first was physical change and chemical change, right? In physical change, we understood that there is a transaction of energy. However, this chapter will be studying more that energy transaction in terms of chemical changes, that is chemical reactions. Chemical reactions involve transaction of energy. If reactions take in energy, then it is heat energy, then it is known as endothermic. If reactions give out energy, it is known as exothermic. Exothermic means the heat exits the reaction. Endothermic means heat enters the reaction. Then we also came upon the concept of system and surroundings. The chemical reaction itself is the system. We study everything from the perspective of the reaction, whereas the surrounding involves the test tube, the reaction mixture, the air around the test tube body, as well as the thermometer inside it. Then what did we study? We also studied that majority of the reactions are exothermic in nature, but there are endothermic reactions also. And as a thumb rule, we studied that all combustion reactions are exothermic. Couple of examples that we saw: zinc dissolved in copper sulfate is an exothermic reaction. Formation of nitrogen monoxide is a endothermic process. And there was a process where we saw nitrogen monoxide formed during in automobile. You have to give a lot of heat. The surrounding should have a heated surrounding. Then only the heat can get into the reaction. One was in automobile chambers, engine chambers, and one was during lightning. That reaction takes place, right? Then we came to reaction pathway diagram. Now this is important for us. In reaction pathway diagram, what did we see? In reaction pathway diagram, we saw that it is a plot between the course of the energy of the reaction versus the reaction progress. So the energy of the reaction is plotted on the y-axis, which will be actually showing you the energy in kilocalorie, and the reaction progress is shown on the x-axis. So the reactions which are exothermic, the heat is released as a part, right? So you will see that the product's energy, the reactant's energy level will be higher. This is what we will study today, why this happens. And you will see that the arrow points downwards, that is, there's a release of energy. Whereas in endothermic cases, it will be opposite. The energy will be more on this side because the energy is absorbed by the system. So, itna hum log last class mein kar chuke the, if you remember. Is there any doubt on this one? Right. So today, right now, don't focus on everything. These are all the salient points. So let's focus on one by one. We will discuss about something called, listen to me and I'll tell you what to focus. We'll talk about a concept called enthalpy. Now let's go back to kinetic theory of matter. What does kinetic theory of matter tell us? Kinetic theory of matter says that matter is composed of small particles, and these particles are always continuous vibration, right? Now, in the case of solid, the vibration is absolutely minimal. In the case of liquid, the vibration is more. In the case of gases, the vibration is maximum. Now, this vibration is happening because the system has some bit of internal energy. Every system has an internal energy with it. You will study this in physics, you will study this in chemistry, everywhere, whenever we study gases. Every system has an internal energy associated with it, and that is known as the enthalpy of the system, denoted by H, whether in physics or in chemistry. Enthalpy is the energy associated with the system, right? When a reaction happens, then what is a reaction? A reaction is where there is a system. Either the system is going to accept energy or the system is going to give out energy. So there will be a change in energy. Which energy? The change in internal energy of the system. Either uska internal energy badhega or uska internal energy ghatega. If the internal energy is getting reduced, that means it is releasing more energy. Exothermic process jaisa hoga. And if the internal energy picks up, that means it will be an endothermic. Hai na? Thus, the change in internal energy is known as the change in enthalpy. In this particular chapter, as well as in chemical kinetics and all, we will be dealing a lot with delta H. Delta stands for change. Say final velocity V, initial velocity say V2, V1. What is the change in velocity? Delta V. Delta V means final minus initial. So our interest will be to find out what is the change. You'll get this, don't worry. Okay, what is the change in enthalpy? So enthalpy, the thermal or heat content of a system. Now here we have a lot of debate also. When we measure temperature in gases, typically in the chapter if you see, we measure temperature in what scale? Kelvin, absolute scale of temperature. And what is temperature? Temperature is a measure of the average kinetic energy. That means if you can make temperature 0 Kelvin, it means average kinetic energy is 0. But this contradicts again kinetic theory of matter, because kinetic theory of matter tells system will always have some sort little bit of energy in it. You can't make the energy absolutely zero. Okay, you can't make the energy absolutely zero of the system. System will always have some bit of energy in it. Have you understood? Now, if you see the 0 Kelvin means you have reduced the enthalpy to absolutely zero. वो possible नहीं है. That is one talk that I wanted to share with you. So we see what we see in this chapter is enthalpy change, heat change during the course of a reaction. Whose heat change? The chemical reaction. That is my system. Also known as the heat of the reaction. You will hear this word like in CBSE and all, they'll always say heat of the reaction, heat of the reaction. Heat of the reaction means what is finally the enthalpy change. बहुत debate होगा इस पे. What is finally the enthalpy change? That is called heat of the reaction. Means for this reaction to happen, either heat has to be thrown out into the system or heat will be taken in the system. That net difference is called the heat of the reaction. Okay, that net difference is called the heat of the reaction. Either you will be taking in heat or you will be rejecting out heat. Okay, that is known as the heat of the reaction. Please understand. That is what is delta H. So I am a system, that is a reaction. I have some initial enthalpy with me. I undergo the reaction. The reaction can be endo or exo. Finally, after the reaction, there will be a change in the enthalpy associated with me. So final enthalpy minus initial enthalpy is change in enthalpy, which is known as delta H. Delta H is also known as the heat of the reaction. It can be positive, it can be negative. Obviously, you have 5 rupees with you. Tomorrow you may end up with 20 rupees, you may end up with 1 rupee. So a change can always be positive or a change can always be negative. अब धीरे धीरे थोड़ा सा इस चीज को you try to marry this with whatever you have learned. आप सोचो, if you are an endothermic reaction, then what are you doing? You are absorbing heat. If you are an exothermic reaction, you are releasing heat. So one thing is for sure, that your heat content at the start of the reaction and at the end of the reaction are different. So there will be a delta H which will come up. And this delta H can be positive, can be negative, depending upon what type of reaction you are doing. Have you understood? So now what we will see is what is the protocol, or you can say what is the accepted norm for delta H. Now let's say the current money in my pocket is 10 rupees. Tomorrow the money in my pocket is 15 rupees. Listen to me. This you will get. There is nothing great. What will you do by writing? You have to understand. This I'll give you in PDF. You'll get it. You understand each block. Then in otherwise you are writing Greek Latin. Okay. So listen to me. Today you have 10 rupees with you. Tomorrow you have 15 rupees with you. I say what is the change in money with you? It depends upon what is the nomenclature or what is the protocol you're using. If you say final money minus initial money, then you have positive 5 rupees with you. If I say the change is today's 5 minus tomorrow's 10, then the change is how much? Negative 5 with you. So there will always be a dispute between how you are seeing and how I am seeing. So in money we say if money goes up, we should always say final minus initial. So यहाँ कैसा है वो भी देखते हैं. So here we say when heat is released from the system, now try to understand this block. Every block is important. We'll understand each block. When heat is released from the system, heat is released from the system means the system is the reaction. Heat exits the system. Exothermic. When heat is released from the system to the surroundings in an exothermic reaction, nothing disputing our thought, the enthalpy of the system decreases and delta H is said to be negative. The enthalpy of the system decreases. If you have little bit of confusion, let us look here. When heat is released, this is the system. System had this much energy. Now the system has this much energy. System has this much energy. The red portion has gone to the surrounding. So if you do final minus initial, don't you think you should get a negative quantity? Is this getting inside your head? Otherwise, you'll make a lot of errors. Initial, this much, system. Final of the system is this much, the reaction. What got released? This got released. So if you want to do what is delta H, like in CBSE when we learn delta H is HP minus HR. Heat of products minus heat of reactants. Cambridge does not use this equation, but I have written it here also. It makes you get easier. Heat of products minus heat of reactants. Obviously, we will get a negative. It is tallying with our course of study. Have you understood? Now, we were also saying, so this minus this is nothing but this gap. Do you agree? This gap is known as your delta H. Another name for it is what? Heat of the reaction. ये reaction होने के लिए इतना heat का transaction होना ही पड़ेगा. अब सवाल ये है, इतना heat सर लेता है कि छोड़ता है? Combustion reaction है. Pathway diagram में what we are seeing, products नीचे उतर गया है, reactants are at a higher level, तो इतना heat छोड़ रहा है. Have you understood now? In an exothermic reaction, the heat of the reaction is negative. What is heat of the reaction? Delta H. What is delta H? Enthalpy change. What is enthalpy change? If you go by CBSE, heat of products minus heat of reactants. That is the heat of the reaction. This much is the final transaction. This is the heat with which you are cooking your food. Are you getting it? Because cooking my food is the surrounding, obviously. Any questions till now? Is it clear? Understood? So let's go back to our blocks, okay? Have we understood this particular block? So we say when heat is released from the system to the surroundings is in an exothermic reaction, the enthalpy of the system decreases. The enthalpy of the system decreases and delta H is negative. This is the protocol. Delta H is negative. And if you want to understand, I have included this C. Delta H is equal to always H products minus H reactants. Negative आएगा ही आएगा. क्या आपको ये चीज समझ में आया? Heat of the reaction. Let us now try to see the same thing for an endothermic reaction. It says when heat is taken in or absorbed, heat is taken in. Heat अंदर घुस रहा है system का. यहाँ देखो heat बाहर आ रहा है system से. When heat, these arrows are very important. When heat is taken in by the system from the surrounding in an endothermic reaction, enthalpy of the system increases. मैं इतना एनर्जी से शुरू किया था, मैंने इतना एनर्जी absorb किया. As a system, my enthalpy has gone up. So what is the change in enthalpy? Final enthalpy minus initial. But we are doing chemistry. So enthalpy of the products minus enthalpy of the reactants. Products ज़्यादा है, reactants कम है, हम positive में आएंगे. Have you understood this or not? Reaction pathway diagram. So what did we discuss today? Srinaga has come, so a little bit of revision. We first understood a term called enthalpy. What is enthalpy? The internal energy associated with any system. It has nothing to do with this chapter. Even in gases, every system has got an enthalpy. तुम्हारे अंदर भी एक enthalpy है, internal energy. और ये जितना कम होगा, उतना ही आप stable हो. ठीक है? Now we are studying chemistry. So for us, it is the internal energy associated with our system, that is our reaction. If this internal energy goes up or goes down, then the enthalpy has changed. So enthalpy becomes delta H. Our job is to understand क्या energy बढ़ा या घटा. So that delta H is what is the protocol for making it positive or negative. We say in an exothermic reaction, when the system releases energy, the system's energy has come down. Obviously, surrounding garam ho gaya hai. Then we say the energy has gone out. And this change in energy is taken as negative. If it disputes your mind, you always remember any change is final minus initial. Final का energy level यहाँ है, ठीक है ना? Final का energy level, I'll do some mutations, don't worry. Final का energy level यहाँ पे है, initial का energy यहाँ है, तो इतना energy का transaction हुआ. This is known as the delta H for this combustion reaction of methane. And this is also known as the heat of the reaction. ये reaction के साथ इतना heat associated है. और ये heat कैसा है? Comes out of the system. And this heat is taken as negative in our protocol. Have you understood? Similarly, if you see an endothermic reaction, the same N2 plus O, as we said, nitrogen monoxide happens in the chamber of an engine and during lightning. Lot of energy is required. So chamber of an engine, the engine chamber is giving you the heat. And during lightning, बहुत ज़्यादा striking हो रहा है, वहाँ से आपको energy मिल रहा है. वैसे ये reaction नहीं हो सकता है. Otherwise, you just imagine, when you learn chemistry, always keep on asking, what is the most abundant gas? Nitrogen. After that, oxygen. ये दोनों अगर रिएक्ट होके नाइट्रोजन मोनोऑक्साइड होगा, हम सब तो मर जाएंगे. Just imagine if it goes on reacting and if the atmosphere, if nitrogen monoxide is getting produced, you will not live. This is a highly toxic gas. ये होने के लिए बहुत गर्म एनवायरनमेंट चाहिए. तो ये लाइटनिंग के दौरान होता है, or else it is happening inside the automobile chamber, engine chamber. So here what is happening? Energy is entering. मैं शुरू किया था इतना एनर्जी से, मेरा अभी एनर्जी लेवल इतना बन गया है. So if you do products minus reactants, you get a positive quantity. So in your Cambridge, they directly say this is positive, this is negative. So endo में delta H is positive, exo delta H is negative. And if you have any doubt, you use this. Delta H is equal to heat of products minus heat of reactants. Have we understood? Chapter is all about energetics. अब हमने reaction देखा, endo exo समझा, pathway समझा. Then we understood in a reaction what is transaction. Now we should also be interested कितना heat निकलता है. Should I use methane or should I use propane? Should I use butane? Should I use kerosene? Should I use pentane? Should I use octane? What type of fuel should I use? At the end of the day, that is what is in our head. If you try to go to grade 8 and you talk about fuel, what is a good fuel? Let us discuss. A fuel should be easy to handle. ऐसा नहीं कि लकड़ी पीठ में ढोके ला रहे हो सिलेंडर. A fuel should be easy to store, safe to store, easy to transport, easy to ignite, should not leave residue. अभी हम गैस जला के आते हैं तो स्टोव गंदा थोड़ी होता है, unless you spill milk over it. यही लकड़ी जला के आएंगे तो सब स्पिल हो जाएगा. And it should be economic. And overall, it should give me high calorific value. गर्म भी तो होना चाहिए. ऐसा अगर फ्यूल लगाए कि इसमें टेम्परेचर ही नहीं आ रहा है तो that is also, that's an ideal fuel. So we should know energy. So ये एनर्जी को कैसे मेजर करते हैं? This किलोजूल जो हमने देखा है ना, this is measured as kilojoules per mole for any reaction. You know what is 1 mole? 1 mole. So if you see this reaction, CH4, try to understand. This is a balanced chemical reaction of combustion of methane. What does it say? 1 mole of methane reacts with 2 moles of oxygen molecules, that is gas, to give you 1 mole of carbon dioxide and 2 moles of water vapor. During this burning process, methane's combustion will release an energy equivalent to 728 kilojoules. That is 728 into 10 to the power 3 joules. 1 मोल मीथेन बर्न करेगा तो 1 मोल मीथेन कितना होता है? कार्बन 12, हाइड्रोजन 4, 16 grams methane. The LPG cylinder that comes to our house is 14.2 kg, we say, of gas should be there. तो उतना जब हम बर्न करेंगे बहुत एनर्जी आएगा. Are you getting it? So 1 mole gives me 728. Have you understood? Here we were only thinking about what is the energy transaction. Now we need to also understand ये मीथेन नहीं होके ब्यूटेन होता तो कितना होता. So now we should talk fuel specific, substance specific. So when we go substance specific, we actually measure it in terms of moles. And we will see also a lot of calculations on this. So 1 mole of methane, when it undergoes complete combustion using 2 moles of oxygen, it releases 1 mole of CO2 and 2 moles of water vapor. And in the process, if this was 1 mole, then this is how much? 728 kilojoule. If this is 1 mole, and this will be taken as negative because this is being released. So what did we understand, children? If a reaction is given to you and they say so and so is a reaction, let's say I now change this reaction. Nitrogen reacts with hydrogen to give you ammonia. 3H2 plus N2, 2NH3 type एक reaction आपको दे दिया, ammonia, and I just say delta H of the reaction is blah blah negative. Immediately it strikes your mind, ये तो exothermic reaction है. ये reaction में reaction होने के बाद reaction ठंडा हो जाएगा, surroundings गर्म होगा. This reaction can be, say whether we can derive heat from this reaction or not. Common question. Yes, we can derive because the delta H of this reaction is negative. And if you see a reaction where the delta H is given as positive, can you derive heat from the? No. This is a energy intensive reaction. ये खाता है energy. ज्यादातर reactions क्या होते हैं? Exothermic. ये अभी देखो तो इसमें कोई भी ब्लॉक अनअटेंडेड है. अब आप 2 मिनट लो सारे ब्लॉक्स को देखने के लिए. ये तो हेडर है, ये आप समझ गए. Then we said these are the 2 protocols. For exothermic protocol, endothermic protocol. Exothermic का diagram, endo का diagram. Then I gave you one more mantra to satisfy positive hota hai ki negative. And this shows you, once you have now understood, you should also be very, very measurement oriented कि एक reaction में कितना energy निकलता है, how much energy comes out. So for methane, what is it? 728. You need not remember these figures. In fact, we will find these figures also, don't worry. Clear? Anyone, any question? Srinika, आप थोड़ा देर आए हैं, देखिए तो. This is the first slide only that we are learning. Is there anything that you did not understand here? Got it? Shall we go to the next one? Okay. Again, in this next one, don't break your head now to copy anything, okay? First, try and understand what, let's just discuss everything. Now, let's go back to our reaction. CH4, so what was our reaction? Our reaction was CH4, sorry. 1 minute. So our reaction was CH4 plus 2O2 gives me CO2 plus 2H2O. ठीक है ना? मीथेन. इस साइड में मीथेन है? नहीं है. इस साइड में कार्बन डाइऑक्साइड है? नहीं है. इस साइड में ऑक्सीजन है? नहीं है. इस साइड में वाटर. That means methane and oxygen transformed to carbon dioxide and water. So if I tell you like a kiddo and I have given you a jigsaw, so suppose a Lego model, ट्रक का मॉडल दिया और इधर बुलक कार्ड बन गया, ऐसे ही तो नहीं बनेगा. आपने ट्रक को तोड़ा होगा और फिर रिकॉम्बिनेशन करके बुलक कार्ड बनाया होगा. So what does that mean? Bonds must have broken and bonds must have been formed. New substances, new alignment, new bond. Old substances have given way to form new substances, means bonds have broken. Now what is a bond? A bond is basically a chemical force of attraction, right? One molecule, one atom is holding another atom, either by means of direct transfer of electron, ionic, or by sharing of electron, covalent, or by metallic structure, जो भी है. Bond is a chemical force of attraction. इसको अगर आपको तोड़ना है, आपको नहीं लगता है आपको एनर्जी देना पड़ेगा? Obviously. ये ब्रेक कब होगा? When will you break? You have to bribe it. You have to give energy. So one thing comes to our mind, bond breaking is an exothermic process. Bond is the system, endothermic process. Whenever a bond is formed, whenever a bond is formed, there is a force of attraction. I want to break it. I want to break this. So I should supply energy to it. Endo. Okay. So our methane has broken down. So let us see the structure of methane. Okay, I'm using this diagram itself. So if you see the structure of methane, methane is CH4. It involves 1, 2, 3, 4. So there are 4 carbon-hydrogen covalent bonds. Do you get it? All these 4 bonds will break. Oxygen to O2. Each O2 is a covalent bond. So we are breaking 2 O double bond O. 2 O double bond O. This much you are breaking. इसमें आपको क्या करना पड़ेगा? Bond breaking takes in energy. आपको energy देना पड़ेगा. इसके बाद whenever bonds are formed, when bond is formed, do you attain stability or not? Obviously. Now question arises, sir, does everything form bond? No. Inert gases will not show all these things because they don't react. Why do substances react? To lower their energy. So whenever you have formed a new substance, your energy level must have decreased. आपका energy level नीचे आना पड़ेगा. तो इसके बाद हमने क्या बनाया? These are all break करने के बाद, these are your new Lego building blocks. All the blocks. You had a truck, you broke the truck, now you are trying to make bullock cart. So सब कुछ आपने फैला दिया. After that, what are you forming? You are forming carbon-oxygen bond. This is one, another carbon. So 2 carbon-oxygen bonds you are forming to form CO2. Then what are you forming? Each water has got how much? Oxygen, hydrogen. Each molecule has got 2. Oxygen, hydrogen, oxygen, hydrogen. And you are forming 2 molecules of, what do you call? Water. So basically, ऐसा दो फॉर्म कर रहे हैं यार, समझ में आया? Didn't you understand? Carbon dioxide is what? C double bond O. Do you know the structure of carbon dioxide? Should I draw? Want me to draw and show? I have no issues. ठीक है? Carbon has got 4 electrons. Carbon 1, 2, 3, 4. Oxygen. Oxygen has how many? 6 on the outermost orbit. 1, 2, 3, 4, 5 and 6. One bond. ऑक्सीजन को 8 मिल गया. दिस ऑक्सीजन इज सैटिस्फाइड. कार्बन 4 से 6 हुआ है अभी भी कार्बन को 2 चाहिए. सो कार्बन पेयर्स विद अनदर ऑक्सीजन. हैव यू अंडरस्टूड दिस? सो व्हाट इज our point of interest is what? Our point of interest is one bond. This is the same thing. 1, 2, 3, 4. So carbon oxygen, 1 bond, 2 bond. And another 1 bond 2 bond on this side. If you see, एक side इधर हुआ, एक side इधर. So another ऐसा 2 bond हुआ. 1, 2, 3, 4. Carbon dioxide formed. Overall सब हिसाब है. ये घर तोड़ने के लिए लेबर ने कितना पैसा लिया, ये घर बनाने के बाद कितना रेंटल इनकम आएगा. Net either I'll be paying from my pocket or I must have earned in my pocket. If you are paying out, money going out, exo. If you are getting money, endo, खत्म. ठीक है, वैसे सोचो. और यहाँ पे क्या हो गया? यहाँ पे हाइड्रोजन ऑक्सीजन. This is two water molecules. In each water molecule it is 1 bond, 1 bond, 1 bond. तो 4 bond हो जाएंगे ना हमारे. Clear. Now let's see. Breaking of bonds require energy. Have you understood what is a bond? A bond is a arrangement between two atoms in which there is a strong force of attraction. It's a chemical energy. And what is the strong force of attraction? That's a sort of chemical energy. You have to supply energy to break this bond. So breaking of bond requires energy. Energy must be taken in to pull the atoms apart. Union तोड़ना है आपको, तो आपको bribe करना ही पड़ेगा. Breaking chemical bond takes in energy from the surroundings. You have to give it. Now here also there will be a question which we'll study. Let's say a reaction of sodium or potassium with water. If you see sodium and potassium, they rapidly undergo reaction. Such type of reactions are known as spontaneous reaction. आपको अलग से एनर्जी देने की जरूरत नहीं है, वो सराउंडिंग की एनर्जी से ही रिएक्ट कर जाएगा. Burning of magnesium in oxygen, is it exothermic? Yes. But दिवाली में सोचो तो आप पेंसिल लेके ऐसे पकड़े ही बैठे रहते हो. Spontaneous है, आपको अलग से एनर्जी देना पड़ता है. If that candle is not there, कैंडल का एनर्जी कम होता है. सो व्हाट यू डू, यू से ए कीर्तन ब्रिंग योर पेंसिल, माय पेंसिल, ऐसे लगा के आप जला लेते हो दिवाली में. यू नीड मोर एनर्जी. इसके बारे में आगे पढ़ेंगे. इसको हम बोलते हैं एक्टिवेशन एनर्जी. जब तक आप एक्टिवेशन एनर्जी नहीं दोगे आगे रिएक्शन बढ़ेगा ही नहीं. रिएक्शन स्टार्ट होने के लिए भी तो थोड़ा एनर्जी चाहिए ना, तो वो आगे पढ़ेंगे. सो नाउ वी से बॉन्ड ब्रेकिंग इज एन एंडोथर्मिक प्रोसेस. टू ब्रेक बॉन्ड नीड्स एनर्जी. वेयर डज द बॉन्ड गेट दिस एनर्जी फ्रॉम द सराउंडिंग. It may be spontaneous, or in the surrounding there might be somebody like me who is giving. अभी methane. Methane is natural gas. Natural gas burner on करने से चलेगा क्या? Like in Delhi and all? No. So you have to give. That is the energy which is coming from the surrounding. Understood? Making chemical bonds gives out energy. Once bond has formed, system stabilize हुआ, वो अपना energy देता है. ठीक है? And bond, so we say bond making is exothermic, bond breaking is endothermic. But remember, this reaction overall is exothermic. As I told you, we will spend money to break our house. We will get rental income from the house that we make. End of the day, we have to say exothermic reactions are what? Where we spend 10 rupees to break our house and we earn rental income of only 2 rupees. So 8 rupees has gone out from the system. Exo. एंडो होने से कैसा होता? 2 rupees to break the house, 8 rupees rental income, so 6 rupees is coming inside my pocket. Fair bit of understanding. Everything understood in this slide? आगे बढ़ते हैं. So some keywords. What are the keywords we have? Bond energy now. What is bond energy? The energy required to break a particular type of bond. If you go back to our slide, we will now calculate some bond energy. So what is this? This is carbon hydrogen bond. In methane, how many carbon hydrogen bonds you have? 4, right? So bond energy is the energy associated with each bond. How to measure it? You don't know. So we will see how much energy is taken to break it. Indirect way of measurement. I have got strength in my hand. Is there a machine? Can you measure? No. So what do you make? You make me fight with a robot and you do the stiffness. If I'm able to break the robot till the point where I'm no more able to break the robot, that is the energy in my hand. So how do you measure bond energy? Energy required to break a bond. So that's what, this is again a keyword. Bond energy is the energy required to break a particular type of covalent bond. Understood? This is a table which is given to you. These informations are usually provided that this is the bond energy for all sorts of bond that we have. Hydrogen, hydrogen bond, carbon, hydrogen, diya hai yahan pe. And we will now do the calculation for our, what do you call, this methane's reaction also. How much did we get? 728. Ye 728 figure aaya kahan se? We will see that. Okay. And one thing you now remember, making bonds is exothermic, mexo. Breaking bond is bendo. Remember these two things. Last class you understood energy exits exo, energy enters endo. That was from the perspective of system. What was the system? The chemical energy. And now we are trying to understand what? In the terms of breaking of bonds. If you break bonds, bendo. If you make bonds, mexo. Mexo. Make से mexo. Break से bendo. ये समझ में आया? Bendo, mexo. Clear? ये डेटा को लेके आगे प्रोसीड करेंगे. Check this and see whether you have not understood anything. In fact, if you want, we can start doing that calculation. Calculator को एक खुला रखो. Somebody also have a calculator. I'm just writing the reaction. You all copy whatever you are copying. I'm just writing the reaction. CH4 plus 2O2 gives me CO2 plus 2H2O. Ready? Covalent. Electrovalent is a different. That's okay. So let's see the left hand side of the reaction. In left hand side, what are you doing, beta? You are basically doing breaking of bonds. Do you agree or not? Breaking. Breaking means bendo. So this side is basically an endothermic process. इधर पे हमको एनर्जी देना पड़ेगा ब्रेक करने के लिए. अच्छा, क्या क्या ब्रेक कर रहे हो? सबसे पहले देखते हैं. वी आर ब्रेकिंग CH4. So you are breaking 4 numbers of carbon hydrogen bond. 4 numbers of carbon hydrogen bond. Let's see carbon hydrogen कितना है. Carbon hydrogen each is 435. Average of 4 in methane. So this is CH4 is 435. Now you calculate. So we will be needing how much? 4 into 435. 1740 kilojoules per mole. This is the expenditure we have to do, right? Then what are you breaking? Oxygen oxygen bond. How many oxygen oxygen bond? 2O2. So you are breaking oxygen oxygen is O2, but you are breaking 2 oxygen oxygen bonds. Oxygen oxygen कितना है देखो तो 498. So 2 into 498. बोलो बच्चा कितना हुआ? 996 किलोजूल पर मोल. कितना हुआ इसको टोटल कीजिए तो 6 9 plus 4 13 3 1 carry over 1 and 9 10 10 and 7 17 1 carry over 1 and 1 2 2736 kilojoule per mole. What is this? This is the total endothermic energy required. इतना एनर्जी हमें देना पड़ेगा. क्लियर हुआ है? समझ में आया तो ठीक है. तो इसको हम क्या लिख सकते हैं? This is our H of the reactants as per CBSE. We'll write it as 2736 kilojoule per mole. Clear, madam? Now let's see what is happening on the RHS. Space is less for me. Have you written this much? Yeah. Then we can rub this also. Okay, RHS में क्या form हो रहा है देखो तो बेटा, CO2. CO2 is what? You have a OC bond and a CO bond. Do you agree? OC is same as CO. CO. So basically you have what? 2 into CO bonds. CO का हिसाब कितना है बेटा देखो तो, CO 803. 2 into 803. How much is it? 1606. 1606 kilojoule per mole. ठीक है बच्चा? And then what do we have? We have 2 H2O. H2O. So in each H2O, what do we have? OHO. ऐसा दो है हमारे पास. ठीक है? So you're basically breaking how many? 4 numbers of OH bond you are breaking. 4 numbers of OH bond. Did you understand? So what is OH? 464. So this is 4 into 464. Tell me how much we should be? 2534. Total करो इसको. H2O. ये उल्टा लिख दिया मैं. 1 minute. Sorry बेटा, ये मैंने उल्टा लिख दिया. This is 1 minute. This should be 2 times of H2O ना, HOH. This is water molecule HOH. 1 bond. OH का कितना बॉन्ड है इसमें? पर मॉलिक्यूल में 2 बॉन्ड है. आप 2H2O बना रहे हो तो 4 बॉन्ड फॉर्म कर रहे हो आप. Have you understood? What is H2O? I am O H H. How many bonds? 1, 2. Each molecule. How many molecules you are making? 2, 4. Hey, what is the total? 6 and 4, 10. 1 carryover, 1 and 3, 4. 6 plus 5, 11, 1. 1, 1, 2, 2 and 2, 4. So heat of the products कितना है? 4140 kilojoule per mole. Now you find out the heat of reaction. Okay, some garbar we have done. What is OH bond? 464. हाँ, who said 2434? Dhruv said 2434. ये हो ही नहीं सकता है. कैलकुलेटर लेके भी कैसे गलत करते हो? How much was it? 2 into 803, 1606. And this one is how much? Kirtan? 4 into 464, 18. How much is the total? 12, 1 and 1, 1 and 8, 9. 8 plus 6, 14. 1 and 1. 3, 4, 9, 2. Oh, that is 6. Nah. Okay, 3, 4. 3462. Let me tally the figures. 3462 and 2736. Okay. Now there is a catch. This is the, now please understand, if you directly apply the formula, what are you seeing right now? The heat. What are you seeing? This, the heat of the reaction is, heat of the reactants is how much? You are supplying in 2736, and while making you are getting how much? No, you are supplying 2736 and you are getting how much? 3462. What is the difference of it? Just do 726 or 728 आना चाहिए. 726. How much did we write in the previous slide? Let's see. That was in books figure. 728. So 726 roughly. Now the issue will be with your sign. Issue will be with your sign. So here is where you have to be very careful now. Now how to find out the delta H of this reaction? Can I rub all these portion, children? Okay. and I'll just write two figures. Okay, these two. This is what I'm deleting. Tell me now, what is the heat? Not heat. Rather, I'll write in my reaction. What is the RHS side? Sorry, on the LHS side, what is the heat that you got? Tell me. 2736. This is kilojoule per mole. And on the RHS, how much did you get? 3462. This is kilojoule per mole. This is here. Do not deal this with as say heat of the reactants and heat of the products. क्योंकि अगर आप अभी reaction कर दोगे, heat of the products minus heat of the reactants, you'll get the figure, but you're not getting that negative. Please understand, you're not getting the negative. Have you understood? If you do, this is not heat of products. This is not the heat of the product. This is what? This is the total energy required. This is not heat of products. There is where children will do confusion. This is what? Energy released. This is energy required and this is energy released. Don't associate this as HP and HR. ये वो नहीं है. Now, what is the reaction? Now, this is where it will come. The enthalpy of the reaction, delta H, is the change of, it is the change of the energy as the reaction proceeds. As the reaction proceeds, what is the change? Please understand that formula is also correct, HP minus HR. But this is not HP. This is not HP. HP means the energy associated with the products. Products का energy कम होता है in the case of exothermic. This is not. This is the energy released. And this was the energy required. So when you go by an energy diagram, we say delta H is total energy needed minus total energy obtained or released. Now you put your figures. So it will be 2736 minus 3462. You get negative 726 kilojoules per mole. Have you understood, children? Again, delta H is definitely HP minus HR. Then, sir, why are we getting that minus ke jagah plus? Because you are foolish, you are using this as HP. This is not HP. HP is the energy associated with the products. So if we go back to our reaction and we go back to our reaction diagram, then you'll see energy associated with the products. What is the energy associated with the products? This is the energy associated with the products. कम है. और ये क्या है? This is the energy associated with the reactants. So you may be asked to do this calculation for another type of reaction where they will give you the bonds. Like say the reaction of ammonia. We will just refer this chart and we can do it. They'll give you what is this bonding. Only thing is that you should write a balanced chemical equation. You should see how many bonds are being broken, how many bonds are being formed. Right? Just if you want to see the reaction of ammonia, then what is the reaction of ammonia? The reaction of ammonia is reaction of nitrogen and oxygen. So it's N2 reacts with H2 to form NH3. Now how do you do it? NH3 means we'll take 3H2, so 3N2, 2NH3. So 1 minute. 1 minute. N2 plus H2 gives you NH3. Okay. So if you make it 2NH3, 2N2, 3 to 6, so 3. This is the balanced equation. So let's do a verbal. Data will be given to us. What will you break? 2 nitrogen bonds. N2. N2. 1 nitrogen bond. Yeah.
726.
726. Which one? This is 726. In this figure, we are getting 726. If you see in the previous one, both 2 and 8, like the book itself says 728, but this is an experimental data. It's 726. Don't bother about that. They will see whether your minus has come and this is correct or not. This is not your headache. Your headache is that negative is your headache, where the negative comes. Let's see this reaction. Exothermic reaction. Right? Why is an exothermic reaction? Making of bonds. नया bond बना है. So what are you breaking first? Nitrogen nitrogen bond, one bond. N2 means one nitrogen nitrogen bond. Nitrogen nitrogen data is given. So you can do this at home. Then what are you breaking? Hydrogen hydrogen, three bonds. Hydrogen hydrogen data is also given. Got it? Then what are you forming? NH3. What is the structure of NH3? NHHH. So you're forming nitrogen hydrogen bonds. One molecule has three bonds. You are getting two molecules. Do we have a nitrogen hydrogen data here? No, nitrogen hydrogen they have not given. So if they give nitrogen hydrogen, we can do the calculation here also. यहाँ पे कितने होंगे? 6 bonds है. 6, because in one molecule there are 3. Clear? Any doubt? Okay. Our last topic. So this is the calculation which we did. Same thing. So चलते हैं. Last topic. Our last topic is something about activation energy. This is our last topic for the chapter. Not a hard chapter, it's very easy. Only thing is that your concept should be clear. Now, what is activation energy and why? Now, we said that majority of the reactions are exothermic. That does not mean that carbon burns in oxygen to form carbon dioxide. Exothermic. I have a lot of coal in my house and my balcony. Doesn't mean that they burn spontaneously. So if the reaction is not spontaneous, the reaction does not propagate. To get that exothermic reaction, you have to first initiate the reaction. Unless reaction, so somebody might tell you, is there any reaction which is exothermic, happens on its own? Yes, take out sodium, it burns vigorously. Take out sodium from kerosene or take out potassium from kerosene, it burns vigorously. Where did it get its energy from? Well, the ambient energy is sufficient to cause that reaction. It does not need any sort of activation energy. So for an ideal fuel, should we have activation energy? Definitely, otherwise it's a big safety hazard. घर में LPG leak कर गया, जल गया आपका. You should have activation. So what is that parameter which decides this? The ignition temperature. The ignition temperature of a fuel should always be more than the ambient temperature. What is the ambient temperature of Hyderabad today? Something around say 17, 20 degree. If your fuel's ignition temperature is 8 degree, लाते ही जल जाएगा वो. तो होना नहीं चाहिए. So in that case, we say additional energy is required to start a reaction. Now, why do we start a reaction? We know that whenever an exothermic reaction is happening, end of the day, bonds are getting made. Mexo. Bonds make होने के लिए, I have a beautiful Lego truck already. I need to make a Lego bullock cart from that set only. How can I do if I don't have some Lego pieces available? तो पहले तो कुछ break करो ना, तो ही कुछ pieces मिलेंगे with which I can start the bullock cart, and thereafter it starts. So some bonds initially have to be broken before a reaction can take place. Then only they produce atoms, which is basically this particular slide. Unless you get this pool of atoms, how does your new bond form? है ना? So for that process, we say that we need some additional energy in order that initially some bonds are broken. So we say, what is an activation energy? Minimum energy required to start a reaction. For a reaction to take place, colliding particles must possess at least this start of energy. This you will again read in chemical kinetics. What happens in a reaction? One particle has to collide with another particle, either breaking or making. And that collision has to happen in such a way that particular face-to-face angle has to happen. For that much of speed should be required, that much of energy should be required. इसीलिए हर वक्त कोलाइड होने से ही बॉन्ड फॉर्म नहीं होगा. Our sir used to say it in much more better way. My chemistry sir in our school days in 11, 12, he was our teenage sir used to say. He used to say, in one look only your love will not happen. That particular moment, that angle, that gift, that thing should happen, then only reaction will take place. Similarly is with this one. It has to come with that amount of speed and collide. समझ रहे हो ना? हिंदी मूवी की तरह मारेंगे हम तुम्हें जरूर, लेकिन वो बंदूक भी हमारी होगी, वो गोली भी हमारी होगी, वो वक्त भी हमारा होगा, वो होना चाहिए उस एटम के साथ। अगर वो नहीं है तो दैट बॉन्ड फॉर्मेशन विल नॉट टेक प्लेस, दैट रिएक्शन विल नॉट। सो टू गिव दैट यू हैव टू गिव समथिंग कॉल्ड एक्टिवेशन एनर्जी। मींस घर तोड़ने के लिए पैसा खर्चा तो करेंगे, यहां तो तोड़ना पड़ेगा, एडिशनली म्युनिसिपैलिटी से परमिशन के लिए भी पैसा खर्चा करना है। You have to take permission from PCOA also. Noise you are going to create, na? This is activation, additional energy. And then finally we will see this much is the heat. This is when Ashmita is burning that matchstick. This is that energy. Have you understood? So we say reactions are a result of collisions between molecules, atoms or ions. In many of these collisions, colliding particles do not have enough energy to react and they just bounce apart. They will collide, but that collision is not going to give rise to a reaction. They'll just bounce apart. Chemical reaction will only happen if the total energy of the colliding particles is greater than the activation energy required. Now just, did you understand the last line? Chemical reaction to happen, you should have energy more than the activation energy. Right now, your particles have energy less than the activation energy. That's why the coal kept in the balcony is not burning. If the coal kept in the balcony, sometimes we say that what happened in California just now? Fire. ये grass 2 महीना पहले क्यों नहीं जला? Because उसको activation energy नहीं मिला. Have you understood? So once the chemical reaction will happen if the total energy of the Californian grass is greater than the required activation energy. On any fine day also, I can create that Californian fire. In that case, I have to light the fire. That is the activation. Today, the temperature soared so much that the overall energy of the system is more than the activation energy. Bas. So my question is now, ask yourself, does the reaction of sodium and potassium not need activation energy? It needs activation energy. But you are conducting the experiment in such an environment, that is Mother Planet Earth, where the ambient temperature is sufficient to provide that activation energy. यही अगर हम शायद किसी आर्कटिक सर्कल में बहुत ठंडा में करते तो शायद नहीं होता. Got it? That's about activation energy. And we say activation energy, so if you see, this is the excess of energy that is required. And finally, this energy is also accounted. थोड़ा देना पड़ेगा. I don't know how many of you people have gone to native place or villages and you have seen a hand pump. देखे हो जहाँ से पानी निकालते हैं. So in summer days you will see that the hand pump में the water goes down. So we in mechanical engineering we call it NPSH, net positive suction head. The suction head has gone down, so the pump is not giving you water. So you will see some people in villages, they'll take one bucket and they'll pour it over the pump. Pump will have a small slit, they'll pour it over and then keep on pumping. कोई एक्टिवेशन. थोड़ा खर्चा करेंगे तो बहुत कुछ आएगा लास्ट में. ठीक है? And let's see our last one. So this is what happens in activation energy in the case of ये diagram भी. Nobody will ask you to draw the diagram, but they'll ask you to interpret the diagram. What is this diagram? This diagram is that of a non-spontaneous exothermic reaction where activation energy is required. And in this case, this is a non-spontaneous endothermic reaction. Here the activation energy will be more. Obviously, इसका तो ये पहले ही भिखारी है ना, ये भिखारी नहीं है इसके पास. Now here comes the concept of again heat of reactants. ये पैदाइशी रिच है, इसको थोड़ा और पैसा दो, टक 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 ये देता रहेगा. ये भिखारी है, ये पैदाइशी गरीब है, इसको कंटिन्यूअसली देते रहना पड़ेगा तो ही ये जाके आगे कुछ दे पाए. That doesn't. So questions you can expect from here is endothermic, exothermic, curves given to you, pathway diagrams. You should be very particular and thorough with pathway diagrams. Pathway diagrams will be given to you. Identify whether the pathway is showing you what? Endo or exo. Then there will be something where they'll label these and ask you what is what? Heat of reaction, enthalpy change. This is the activation energy. So when we go to chemical kinetics, we will be doing calculation based on this also. ये भी तो खर्चा है ना, end of the day. But this is very meager. So if you see atom bomb, or if you see nuclear reaction also, you'll always see one neutron will be required which will go and bomb, the bombing neutron. एक्टिवेशन देना है, एक्टिवेशन नहीं है तो प्रोसेस अनकंट्रोल्ड है. Any spontaneous with energy is a very, very dangerous thing. Activation is mandatorily required. Otherwise, you'll land up in problem. Bolo now. This is fine. We have no more slides. Anything in today's content that you have not understood, this concludes our particular this chapter. But there are questions. I mean, from both the books you can go, and there will be questions on something like ammonia, hydrogen peroxide decomposes to give you 2H2. Use the following values. See, they have given you the values and they have said, and then you determine whether it is exo or endo. Please do 1 or 2 questions at home. Yep. ये उल्टा है लेकिन हाँ, hydrogen peroxide decomposes. Any decomposition is a endo. In this case, when you solve it, you should get your final delta H as positive. Decomposition. Or else you can make your own equations. CaCO3 takes in heat and forms CaO and CO2. Then again, you take the values from the book. What all you should know, what all bonds you are breaking. No one will get in this locked. What all bonds you are breaking, what all bonds you are forming. And for that, you will have a chart. Yeah. So they have given another exam type question, N2 plus 3H2. The data are given here. Nitrogen, hydrogen was not there with us, right? This is there in your book. Your book is there. You can do. And even in your book, same example ही रहता है, ज़्यादा और कुछ नहीं. Now, I'm stopping the recording here. Question